Well, all right. T-2 on the end of the workshop. We've got 2 days today. So good morning, Texas. Good morning, world. Where are we at? So some of the outcomes of the program. On collaborative design, yesterday we added one little step. We discussed a little bit about how to make collaboration more effective. So we put up a Scrummy board with evident tasks. So maybe I can start with a little bit on the collaborative development method, since that's a big outcome for people learning how to do that effectively as a team. So let's go to a page. So just back to overview, we've got people in different locations. Right now, 3 locations in the world. There's also a couple of people in other locations who are doing remote collaboration, like Jeremy, for example. He's been cranking CAD designs up into the wiki. The way it can work is if it's digital, it can scale. So we're digitizing things and putting them on the internet and collaborating that way. Some of the highlights of this process are that we just one example that stands out to me is we did for example, for the plotter attachment in this whole process, we did a version here. The European people picked it up and actually derived from it and made an addition to the pen plotter. So that's an example, just one example of how collaboration could work. At present, we're limited by the number of people. We took on a complex project, which was the Raspberry Pi tablet. Now we have 3 people in Texas here, a bunch of people in Europe. We're a little scattered in that some people are farther behind and they're not working on a Pi tablet. But yesterday, for example, we were struggling with an idea of, okay, there's a lot of pieces on a Pi tablet, from software to firmware to power handling to the structure. And the breakdown of tasks in that point is somewhat difficult, because each little task takes a bit of time. Like, for example, if you're going to break down the project into mechanical design or just a CAD design, each of the pieces wants to be a separate CAD file in a part library, and each of the pieces is going to take like an hour to a couple hours to do. And if for everything, like for example, we want to get the Raspberry Pi itself as a CAD file into the system. Now maybe you can find it on GrabCAD or another source where there's already a 3D CAD file. That could work. That's one approach. Or we can draw it from scratch using minimal features. But I can tell you now that if you, for example, download it, typically the downloads you get, like say GrabCAD, this file would be, we would expect it to be a few megabytes. So already there we're okay, that's not really good, because a few megabytes of a file, you put a couple more files like that, and in FreeCAD this becomes unbearably slow unless you have a high-end computer or with GPU and stuff like that. So typically we do simplification, like we start drawing up the things from scratch without really looking much on what's available over the internet. But also those larger files, we should download them and make note that they are there, in case we have some more detailed design that we need to make from it. Because, for example, if we have the CAD file, there might be KiCad schematics available. KiCad and FreeCAD actually work together. You can take an image from a file from KiCad when you do the design. Say there's a design file for the Raspberry Pi in KiCad. You can import it into FreeCAD, so you actually get this nice full 3D CAD model within FreeCAD. So that's useful, and then you can derive, like say you wanted to make, well, circuits with a circuit mill. We can do it. Some of the evolution, for example, on the electronics part would be, we did a little initial bit of a CNC hole drill, so the Richmond team did it. Now, the current design of the D3D Universal does not really get you a good kind of a circuit mill, but it absolutely can be modified. The parts that we have already, you definitely need a little more structure, but that would be a power user kind of a project. Somebody from the Steam camp right now can say, oh, I'm going to turn this into actually a viable small-scale mill for circuits. Definitely doable. You'd have to redo the axis, like the 3D printed pieces, so that they're larger and more stiff, so you don't get absolutely any wobble in the axes. You'd really tighten it up, probably make the size a little smaller. Instead of 6 inches, you might end up with like 2 by 3 inches or 3 by 3 inches, which is like 1/4 the size, but much more stiff and closer to the body. So you can definitely derive from this as a collaborative effort. But this leads into, okay, there's a large role division that if we wanted to have this blown out amazing experience, the more people the better, and it is doable that we can divide things into parts. So talking about dividing things into parts, let's actually take a look at one thing that we haven't done. So we, on one side, we have collaborative literacy, the OSC collaboration protocol. So take a look at that, and then I'll go into one aspect of it, which is the development template, which is something we've seen in practice yesterday of how that was kind of under the work we were doing yesterday, but let me make that explicit. So if you look at the collaboration protocol, what we've done so far, do the work logs. We've been doing that. Most people have them. You have an index of all the work logs on a working page. So we've got the January working page. We also have the part library page for the Raspberry Pi tablet, which is our main project. And we also said that we will continue that. So we have also a Scrummy that we added to this. So this is on the OSC collaboration protocol page. We publish early and often. Document yourself out of existence kind of deal. That's the underlying theory. So that you're not blocking anything. Document yourself out of existence. Put your stuff on a log. And starting with the logs, I must emphasize something like, for example, Jessica log has a bunch of stuff on an etching of the board. Tom has got some. I've got some. Well, I don't have much. I've got a lot of pictures. But at that point, after we have all the logs and we have the team page, we can collate all of that on separate project pages. So now we have basically the STEAM Camp 2020 curriculum page, but in there we can start making those. We have individual documents for each day. Now they're lean right now. They're just got maybe some basic links. It would be appropriate that we then take all the info we have and put them into the Google Docs, which can then serve as curriculum for future people. And then we'll make iterations, we'll make improvements. Like for example, here we discussed how we can make the power circuit much simpler by eliminating the light dimmer, by eliminating the gate driver transistor. So instead of using 2 transistors, using 1. Potentially, that we definitely want to do that because that complicated the circuit quite a bit. I mean, really, to streamline things so you get the concepts with the minimal effort. Like right now, we're taking a whole day to develop something. In future STEAM camps, it should be more like, okay, that we can do in 1 hour, move on to a richer curriculum, more learning around that. So from the work logs and existing documents, we can now start refining. So this is, once again, get it up into the wiki, and the second step is organization. So for example, everybody in the camp right now, we encourage you to take all the assets that you have, because we know there's many logs. We can put that, I would suggest we put that all into the working docs for the individual days of the STEAM camp. Like there's on the January page, which is called it's called the January 2020 Open Source Microfactory STEAM Camp. On it, we have a link definitely to the original curriculum, which is the January 2020 STEAM Camp program. There's a link there. So we can now backfill all those documents with the new experience, new pictures, videos, and everything else, and keep streamlining that. So basically going from all the logs and all the assets, I mean, people's Google Drives with photos, Facebook pages with photos, start collecting that all into much more information-dense documents that serve for future workshops. So continuing on the collaboration ecology here, basic OSC workflow in FreeCAD. The endpoint of that is the ability to, within 5 minutes, create a 3D object, put a feature on it, put a feature on that feature, and go straight to the printer and print it out. 5 minutes. If you can do that, that means you can slice, you can CAD, you have a basic prototyping workflow under you. And we can do that exercise just to show that. Basic workflow includes making the files, uploading them, and creating part libraries, which is the next aspect of the collaboration ecology there. Part libraries are very useful as a visual representation. You can see immediately what's up there. There's a visual part history above the part library where you can see how people have modified a certain file from one step to the next. Like, for example, if you take a look at the part library for the Raspberry Pi tablet, which we have been working on over the last 2 days, there's a working dock on top, and you see a nice part library taking shape. So, for example, there was an initial battery holder. The last picture in the part library, visual history, is the most updated one with a bottom, which I determined here that we need a bottom in order to adhere to the bed better because it was warping when we were printing. So you can see somewhat of a visual history, and that could also be annotated, and a full-time curator, an online curator should be here. Given that we don't have sufficient amount of people, we don't have a full-time curator, basically the collaboration manager, who would be in the background, perhaps integrating all the logs into the documents so that we have more organized more quickly. So those are part libraries that, it's good. I mean, 2 or 3 people are now uploading to that part library. I know myself, Jeremy, I think Chris has done some. Visual histories. So try to upload the FreeCAD files as soon as you have them. So if you started it and you drew up an initial sketch, throw that up there. It's your backup, and also other people can go from it. We learned how to embed Google presentations. And then I put up a little summary process on rapid prototyping using a second Toyota paradox. And the second Toyota paradox is an important concept which simply says it's essentially what we do here, and that is you do excessive prototyping on all the elements and you don't actually build the whole thing out until you've done a lot of prototyping. So you draw out the prototyping on each individual part as far as you can, like in a ridiculous amount, like Toyota does that. Like they put so much effort, instead of like standard like 2 or 3 prototypes, Toyota will go through like 12 or 20, but they end up making really good products. And so that's the idea of the rapid iterative prototyping. And you can see, so from if you click on that on the OSC Collaboration Ecology page, Collaboration Protocol page, you get taken straight to this one diagram in pink and green here, where there's also a link to test-driven design. So we do test-driven design. Read up on that. The test-driven design is a complex circle where there's inputs and outputs happening on a continuous basis, and those are work products that then go on to inform successive iterations of the prototyping. Right now in the rapid prototyping, the 3D printer is good, but yesterday when I was thinking about it, like say we're prototyping the case and how everything fits together, I would say it's also useful if we would add a simple laser cutter, like even a 4-watt laser cutter that can cut pieces of thin cardboard, because out of that, if you had a means to generate like foldable files from laser cutting, there's actually a workbench within FreeCAD that I believe does exactly that. It's the sheet metal workbench where you design 3D objects and this gets out the CAD or gets out the DXF files in a way that are already, like it might have the bends. It pretty much takes a 3D shape and splits it into a flat object that can be CNC cut. That's very useful because in fact it's exactly what we do with the brick press. The brick press is all digitally cut, as an example, and that's how we want to make all machines digitally cut. So it's rapid, turning a 1-week build to a single-day build. The way we do it is we take a 3D object and then convert it into basically flats that are cut out of a flat sheet, and then we weld them together into the 3D shapes. That's very convenient because that can use the digital torch table to facilitate that. And in this process here, we can do something like that, doing prototyping in paper where you can have the the 3D image. Now say you design your case for the Arduino, for the Raspberry Pi. Much more rapid than a printer. Like a printer would take you an hour. The laser cutter would take you 5 minutes, so you can see all the fit. So I was kind of thinking that, yeah, that would be really useful, and not a far cry. Like we wanted to have that. Well, we want the laser cutter, tiny laser cutter. It's just a laser diode that can fit on a D3D Universal and do this light duty cutting. Only issue being, like, you got to wear glasses, make sure you're safe, maybe put an enclosure on that so that you can do this more rapid prototyping. But on the Colab and rapid prototyping workflow, we have the elements that we already use: Scrummy, working docs, work logs, part libraries, FreeCAD STL to 3D printer. So I think the two gaps in there are KeyCAD to circuit mill and the FreeCAD to laser cutter. So if you could add those, we can really robustify the whole process here. But of course, with the 3D printer, it's still pretty good. But I could just see, like, the differences between 1 hour or say you do a big part overnight. You can do the very rapid prototyping with the laser cutter. Like, for example, when we did the brick press, we actually had one person do the laser cut model concurrently, so we can take a look at that as the model as we were building it. And for the Summer of Extreme Design build, we want to do exactly that. Before we build anything in full metal, half-inch steel, we're going to do everything in 3D prints to verify mechanical fit, and then possibly add little electric motors so you see how this thing actually works as a simulation of the hydraulic motors at full scale. So this is where the battery packs here would be important. And between the laser cut and the 3D printed, the workflow for the summer is such that, yes, we're not making mistakes on things like geometrical fit that could be solved in a scale prototype. So that kind of stuff we want to eliminate completely using the rapid prototyping tools. Now I want to get back to, so on a collaboration protocol, more like the power user stuff is understanding wiki taxonomy. So there's a whole page on that. Study it, wiki taxonomy, and then start a development template. So if you understand the taxonomy, you can start filling in development templates. So let's just take a look at the development template, because that's what we were actually doing yesterday without knowing that. I mean, there's a sequence of steps that for any development project you take, and I just noticed the development template link is wrong there, so went to the OSE naming convention. So we have a naming convention, and like the people in Europe, we're talking about versioning like the second or third day. Please take a look at that page and modify it and make suggestions. It's openly editable. So for a simple development template, yesterday we were kind of debating, over 2 days, okay, how do you get this Pi tablet done with all these people? We don't have enough direction. So some of the structure you can start adding on top of that process is following a generic product development process. And what is that? So if you go to the simple development spreadsheet, development template page on the wiki, you have a simple development template which has a total of 20 steps that are all followed in non-sequence, but sometimes in sequence. This is rapid iterative development. So start with requirements of value proposition. You want to go to industry standards. Like, for example, in yesterday's development, we did not consider industry standards. Like, the industry standards would be, who else has built one of these tablets? That should be an exhaustive search, and in fact, the follow-up emails and calls to people who have done it, and we're not repeating mistakes. Like, what we're doing today, probably hundreds of people have done this. Now, the issue is that nobody publishes it in an accessible way, and that's the gap we're trying to fill here. We're going to nail this, we're going to productize this, we're going to document this. But with study of industry standards, there are some Pi tablets out there. There are definitely a lot of DIY projects that we want to study and build from. So we didn't really do that, but I'd say since our project is unique, I mean, and we have, well, not that it's unique, it is unique, but more the idea that we didn't have enough people to fill all these roles. We didn't really get in there. We just started, okay, let's start fitting these parts. We have them right in front of us. We have particular parts, and we have particular physical constraints that come with our parts. So to find something that's exact like this, the chance of that is just about zero, but the chance is very high that we find components, parts of what we're building that actually already exists. So that's the study of industry standards, both industry standards as in mainstream industry, and then DIY industry standards, or so-called just looking at what other DIY projects have done. So then step 3, you get into conceptual design. That's our Google Docs. We start identifying concepts. We also document the requirements in there. We can also use the Google Doc for industry standards. We did a little bit on the modular breakdown, and once you have the concept, so modular breakdown is step 4, which is really modular breakdown / interface design. We're doing some interface design. For example, some of the files that Jeremy generated, and I generated the file for the Raspberry Pi, they have interface information, meaning the hole, for example, the holes with which they're mounted. So that's implicitly there's interface design in there already that informs how you design it. So step 5 is 3D CAD, which is now getting into the technical design. Now CAD could be just like the conceptual design. They're quite related. The limit of conceptual design is a technical design, and the limit of CAD and technical design could be represented by CAD, pending that CAD being accurate. So the limit of CAD in its lowbrow form is just a conceptual design. Like if none of it is accurate, then it's primarily a concept, not a technical design. So and then when you so for your awareness, when you see a CAD file or even a conceptual design, it could be that the conceptual design is actually more accurate than a CAD file in some cases. So you have to know what you're dealing with. You have to be able to assess, okay, is this CAD file technically correct or is it not? Or is it just a model? And same for the conceptual design. How much of that is BS design, just generic, versus actually technically correct with the right dimensions, with the right materials, right connections, and so forth. But either can get you really far, 3D CAD and conceptual design. So ideally from conceptual design you get it out into 3D CAD fully, you digitize it, you split it apart into modules, and then many people can collaborate. And now we're going through the development steps, so as we're collaborating, there's iterations for each step, and you can even break down each module into all these development steps, so you can see like how one product will have these 20 development steps. So the Pi tablet has 20 development steps. Well, you can do the same for each component, like the operating system. That can have its own full set of 20 steps for it, and say there's like the light module or the power module. They're each projects of their own. Each of them could develop into a complex project, like the battery pack evolves into a cordless welder power supply, etc. So right here we're seeing that with the Pi project you have so there's 20 steps that in a simple template. The more complex template has more like 40 steps, and we have 20 steps at one level, but if you break it down to the modules, say 10 modules, right there you have 200 items that people can be working on. And then you have iterations of those items, say typically 3 iterations or so or more. So there's, in any project, you can have this very large granular breakdown. But back to some of the other aspects of it. So 3D CAD, calculations are good. How do you know how much power the battery pack's going to have? How fast can you charge it? Etc. Those are all things that should go into calculations. Here you might have and you can click on each of these under simple template and it'll get you a full description of what it is, but calculations could be anything. It could be, what is the weight of this? So you're actually summing up all the individual component weights. You can have like thermal calculations for like how much power do we need to cool off the LED that we're using. So you can do calculations on a lot of different elements. Electronics design. So electronics design would include things like the charging system, the battery system, battery management, wiring and plumbing. So that's how we This is a generic template, so plumbing and wiring are a similar concept. It's how you connect things together to make some kind of a fluid flow, whether that fluid is electrons or water or hydraulic fluid or anything else. Software. So software is the firmware and the operating system, like for the Pi. That's a whole big deal right there. We're negotiating how we can best do it right now, because we noticed that the keyboard with stock Raspbian is not highly usable, so we want to use something that's very usable, like on an Android phone. So maybe we even install Android on our Raspberry Pis. So that's the design aspects, 9 elements there. Then you go into bill of materials, and the plain bill of materials, item number 10 is BOM, just an itemized list of parts. The most important things there being a description, the quantity, a link to the specific identifier. For example, a link on Amazon that will get you to spec sheets and so forth. But don't just say use a 1K resistor. That tells me nothing. It's like, okay, what size is it? What power handling capacity? Like, what is the source? There might be actually different sources, and they might work differently and not be adequate for the project. So do the sourcing, identify it to a degenerated. So the degeneracy concept comes in. The description should be degenerate, i.e., it gives you one choice of what you can use. That's definitely is going to work, and maybe it has many others that may work or other substitutes. VBOM, visual bill of materials. A lot of times when we're communicating this rapidly to others, it's useful to have a visual breakdown of a project where you hyperlink in Google Docs to the actual sourcing or more information. So instead of using a part diagram, you can actually do real images that a lot of times look much different than your diagrams. So that's very useful for people to get oriented rapidly. Visual BOMs are particularly useful when we're designing hydraulics for tractors, because there's a ton of fittings and parts in there, and we simply go very granularly, cut and paste little images with their sourcing. So if you want to source this, modify it, it's really easy to see, okay, this is the part I'm working with, and so forth. CAM files. CAM files are your computer-assisted manufacturing files, so that will be the G-code files, or laser cutting files, or CNC milling files. So basically that which comes out of a CAD package, the translation for whatever machine tool you have. Under bill of materials, there's also a cut list. Cut lists are very important. You can say we need 6 feet of rods for the printer, which is the current case. Each is 12 inch, and we got 6 of them, and then one more for the spool holder. But the cut list would be, okay, 6 pieces, 12 inches. So that somebody who's making it, you don't have to have them guess to what parts you need. Okay, now on the build. The build part, so item 14 is build instructions. Build instructions are a big part. If you can have explicit build instructions, then in theory you don't need an instructor to tell you what to do if those instructions are good. Now those instructions can get really high quality, like for example augmented reality instructionals through your cell phone, or then you get into higher level stuff like augmented reality glasses, which give you superposed information in your field of view, where as you're building it you're getting extra information. So that's build instructionals could be advanced, and that's like a specialized version of build instructions. But build instructions at a basic form are something on a web or a printable thing that you can give, and right now printable things are still useful for some people who don't use the computer. Okay, fabrication drawings. So those are technical drawings. You can get those out using the dimensioning workbench in FreeCAD, drawing dimensioning workbench in FreeCAD. So these are technical diagrams. So say you can give it to a fab shop, and they will understand how to cut your materials. Or you give fabrication drawings to somebody else, like a circuit maker, to make you a circuit. Explode part diagrams. Those are very useful in that they break down complex assembly into individual parts. It's very useful. You see them in the back of maintenance manuals. That's something we want to do as well. FreeCAD has exploded part animation capacity, so you can take any kind of an image any kind of object, and you can explode it. You can catch a video of it to do a quick run through of how something is built. You can build instructionals out of that. Production engineering, so that's all the details of how you manufacture it. What tools are you using? What settings are you using? What's your workflow? What's your workshop layout? Timing schedules, personnel schedules, all of that. And for distributed production, with production engineering, with distributed production engineering, which is what we're trying to develop, basically our production engineering boils down to a microfactory in every city. So basically, how do you manage this process on a granular level of a community-based manufacturing facility that's easy to replicate? With that comes distributed quality control, where you document your quality control procedures so everyone can follow them in an easy way. Okay, step 18, we're going to data collection. So build pictures and video. So after you build something, document it. Let others learn from your mistakes. Do the stuff that, take pictures of stuff that didn't come out. Messed up prints, bad etched etched circuits, exploded MOSFETs and things. Take a picture of that and let people know what works and what doesn't. So that's build pictures and video. That lends itself to nice promotional materials as well, with a lot of sparks, which we have a lot in our program. Then you got some more formal data collection. There's actually a form on the wiki. It's a very simple thing. It's just a spreadsheet. It's on a page called data on the wiki. It's a spreadsheet. It's a form. Just fill in data points like, it took me 2 hours to build the universal axis, or whatever. Just data points that are all over the place, from production engineering to how something works to improvements. Collect all the data you can, and then we can go back through that log. It's just a spreadsheet, and make that part of the normal work process. That's very important. What are we documenting so we can learn and build from it, and other people in other locations can not go through those mistakes. So if we have that level of understanding, that we can now check, okay, here's data, here's any project. It should have a link at a wiki page for a project. Here's the data section. So these are all things that go into a single project. Future work also, so suggestions for improvements, like for example, out of the Steam Camp, if we have a page on the Steam Camp, I would say make an improvement and make the Arduino simpler to build, make the power electronics circuit easier to build, maybe add a small laser cutter now, and then we're throwing some light and sparks around and making it more exciting. So certain improvements that become obvious after you go through the experience. Before you go through it, you don't have as much information. After the process, you get a lot of insight that's useful to build upon. So let's not lose it. Put that in either data collection or future work suggestions. So these are 20 steps for a basic template. We typically embed these. We actually have a wiki template where you just call it in one line, and it sets this up for you with the hyperlinks there. This here, what you see on a simple template page, on the development spreadsheet template page on the wiki, that's actually an embedded Google Doc. So you can do an embedded Google Doc, but to be more like building upon the wiki infrastructure and using wiki words and hyperlinks within the wiki, we have a simple template. We can refine that template to format it better, and possibly do things like generate automatic burn down graphs from it. So as you fill in, you'll notice that in the development template, you have a column that one is the deliverable, second is the link to work product. So once you have the work product, put a link in there. And then we have a third column, which is level of completion from 1 to 10. So if you can parse that template for the number in the third column, which is the level of completion, you can generate an automatic burn down graph. And we actually have that capacity by using an external app. So if you type in the URL of this Google template into it, you can get a burn down graph. That's on the OSE dev, capital OSE, small DEV. That's on the OSE dev page. You can actually generate burn down graphs right now. We've done some, but it takes more people to manage that, and it should be an automated process that when we set up a development template, it should automatically generate a burn down graph from it. That would be a great improvement for the wiki. So someone who can program that up would be appreciated. So that's the basics of the development template process. So yesterday we were going through, just to review what we were doing on the Raspberry Pi tablet. We're doing several of these steps. Like, what were we doing? We were doing conceptual design, we're getting into some technical design, we were doing requirements, we're doing a lot of conceptual work, like still about how to put it together, but also getting into the actual bills of materials and wiring diagrams and so forth. So a lot of those things are actually jumbled up into this working doc. In order to make that more organized, we can actually link from the development template if we set it up. We haven't set it up for this project, but we can actually make links where we say that particular link links to a specific page in a Google Doc, so that when you click on it, you get straight to that info without having to wade through, say, 25 or 50 pages of a Google Doc. So the large purpose of the dev template is to have one-click access to any information asset. And combined with wiki taxonomy and naming convention, you can in principle orient yourself around just about anything on the wiki. So that's about it on that. And so today we're continuing with the Raspberry Pi tablet. Now, some of the important milestones that we want to reach. I've been still printing out more battery packs. I haven't checked how it turned out overnight, but I printed one with basically using brim, because the thing was peeling off the bed, and I put it back on it so that it's got more adhesion surface, so hopefully we've got that. The milestone for the battery packs, since I mentioned this is only the beginning.
It's fully charged.
Excellent. Milestone is that we're able to do these simple scalable battery packs. Like right now, I want to show that we can take like 4 of these battery stacks. You have we have the Frankenstein bolt version with the bolts sticking out, which allows you to connect it anyway just by wrapping wires around the bolts. That's one way. That would be V0.1 of a scalable battery pack. You can we have enough here for 3, you can stack 3 of them together and definitely do the welder application, for example. Well, for the welder application, we need 2 of them, so 10 batteries, 37 volts. That will get you 1/16 electrode welding. But think about this for the beginning of electric power cubes, vehicles, other battery packs that can be from a single cell to multiple cells. So we've got the single battery holder, we've got a 6-fold battery holder. Is that I think 5-fold battery holder? 5-fold battery holder. We can parameterize that, make a battery holder construction set macro on the wiki where you just select the number of cells and it draws it automatically. That's a definite thing we can do within FreeCAD. That's low-hanging fruit. Using spreadsheets within FreeCAD, you can basically type in the parameter and it draws out the battery pack for you. I think we've got a nice way to do the connections. We did actually a very nice battery pack where Tom took the existing design. We put a wire through, so actually we want to modify the file to put a through hole. So you stick a wire under where the screws go, so that when you screw the screw down, a wire connection is made so you can connect the 5 cells in parallel. If you're doing series, you need to connect 2 adjacent cells to one another, so you can have a short wire inside that hole, or just the Frankenstein bolts, where you're wrapping the wire around the Frankenstein bolts. So outcomes, we want to do scalable battery packs. We already have a basic charging circuit right here. So actually, Tom, this is not online yet, is it? We just got the LED connected. We've charged a 5-volt battery pack using the simple, the small battery charger, the 1-amp charger. It charged overnight. It should take, the calculations say that if you got 3 amp hours, actually, each battery is 3.7 volts. It's got about 10 watts of stored power. If it's about 3 volts, it's about 3 amp hours of power, like maybe 2.5 or so. So each battery using a 1-amp charger will take 2.5 hours. So overnight you charge a 5-volt battery pack using the very tiny charger. That's the basic calculation there. So we've been able to do that. We're able to now take the output, taking the batteries, connect it to the boost converter that's in your kit. So the little blue thing, the adjustable converter that you can set the voltage from 0 to 36. It's a 36 volt boost converter that takes any input of voltage and boosts it up accordingly. So we connected that to our LED controller, the LED control circuit, and connected it to an LED, so now we can light an LED. Like, holy cow, that's awesome. So that's something we're adding on as a module to the Raspberry Pi tablet. Right now we're just thinking of a simple button, push button, so we can have this as your light source for when you're out in the wild, in the dark. So basically, this normal camera kind of light, kind of a thing. We're intending this to be actually like a film studio light, in which case we'd have to put it on probably on a heatsink, because right now this is pretty light. It's low voltage, or this is not
very low.
We've got it set up right now where we're on very low power on this LED.
Battery is probably discharged too.
Yeah. But the LED you have, that's 10 watts of power. That's a lot. That's going to be very, very bright. That's enough for a camera light.
That's a lot of heat to dissipate.
Yeah, so you got to put it on a heatsink that's included in your kit. Okay, so there's that. So we got milestones of batteries. We've got the boost converters working, the light working. So now we can charge and discharge batteries effectively. We're working that in parallel. But for now, like, we're going to be very careful about putting that power into the Raspberry Pi, and until we're very confident that we understand everything, we're not going to use the batteries for the Raspberry Pi. We're going to fry it. So right now we're just going off the wall power outlet, but maybe we can figure that out, that we're saying we're confident enough and the voltage is stable, so that when we put in the 5 volts from the boost converter into the Raspberry Pi, we're not going to fry it. So other milestones, in the last 2 days, if one of you guys can make a functional keyboard on a tablet, I mean, my thought is either software that works on Raspbian that works really well, but maybe Raspbian is just not set up for it. I know that Android systems are well set up for pop-up keyboards, but maybe we can divvy that up, and you guys with a good internet connection, we can't really do that here. We're limited on bandwidth. It was a pain to download everything already. Maybe we can divvy into that. Continue working on a battery case. Right now it seems that the best choice is, we were talking here, like Don suggested, like just a fat battery pack that goes to the back. So we stack the Raspberry Pi behind the screen and the battery pack behind that, so that we're not expanding the Pi tablet to like a large front area. So as long as you're within about 3 inches, you can still hold the Raspberry Pi in your hands and still use the keyboard like you're typing on a cell phone. So we're kind of looking at that pattern. The files, there's a bunch of files up in the part library. So I did the Raspberry Pi. We've got the case for it. We want to do a case for the screen. We're moving along on all these aspects and just putting it together. Found that the wires that come with the system, they're quite stiff, so they're not the greatest, but they are. Gabe, would you mind turning off your video? Gabe, we're in energy conservation or bandwidth conservation mode here, since we don't have a lot of video. So I'm talking to Gabe tonight, actually, about Summer of Extreme Design Build. So maybe we can get some feedback in. And yesterday we fed back a little bit on how the collaborative development process is going and what we can improve. But maybe we can comment on that a little bit, and then get into the day. So maybe hear first where Michel's team is in Europe, and go from there. Michel, you want to fill us in where you are on your side? Or Jeremy or Chris? Jeremy, we can't hear you if you are speaking. Maybe we gotta. Is that your side? Let me just try refreshing here. Let's see. We have sound. We have sound. Oh, there we go.
Hey, stand by, everybody.
Okay, now we can hear you.
Okay.
Can you hear me?
Yes,
Michelle?
we can.
Okay. Well, we haven't touched the Raspberry Pi tablet yet because people here prefer working further on plotter and mostly the drill, making the drill files.
Wow.
Routing a circuit board.
Wow.
Peter is looking into that right now. So making the files for routing and drilling the circuit board, basic Arduino.
Yeah.
Holger is looking into the dimmer, but made in KiCad. They made the circuit board together, Holger and Peter. And now Peter is looking into the assembly.
Wow. Okay. That's cool. So you guys pretty much are going in where the interest is there, which is good. You're definitely making developments, moving the thing forward. For the only suggestion I would have on a circuit mill, you probably want to print yourself new parts where you got much more stiff grab onto the y-axis and between the z-axis and the x-axis. You really need to beef up that connection there to make it much more stable, and of course reduce the milling size so you're not cantilevered so far out on the axis. But no, that's excellent. But yeah, if you can, I would definitely suggest making a mod on the parts. Are you guys thinking about a mod on the parts, or just like adding another axis so that you have 2-point support for the Z?
For the moment, not yet. There isn't a second Z-axis. We're gonna try as it is. Move very slowly because it isn't really a router bit, but a drill bit with a flat end. So we just want to test if it's possible to route a circuit board very slowly with that bit that we have. The bit that came with the kit, or no, I didn't. Did I send it to you? I'm not sure. That came with the kit. The one that we put on the 555 motor. Yeah. Well, we don't know if it's possible, but it's a test. Yeah. Would be nice. We're gonna try to, instead of having a spring action on the drill, which is a bit difficult for the moment, like put something under the circuit board that has some spring action, so it can compensate for a bed that's not completely level. But it's all, that's certain things we want to try out, like simplify the concept. A stable axis would be very nice, of course, but we're trying to do with what we have.
That's really cool. Michel, what are you using for the pathing generation? Are you using FreeCAD's path toolbench, or?
No, Peter has used the Inkscape add-on, I think.
Cool.
The export from KiCad. So the board was made in KiCad, and then an export ended up in Inkscape because it's not very useful. The SVG that is exported from KiCad, you can't use it immediately for routing.
Yeah, I see. Well, yeah. I was just going to suggest, because I was doing some similar experiments from with my with the mill attachment from Inkscape and also from FreeCAD's path. The one thing I noticed that Inkscape does not automatically put the G20 G29, the auto level command. So when you insert that code at the top of the G code, it does the pathing much more level.
Okay.
Yes. So the workflow now is to have the circuit board designed in KiCad, and then from there we can generate an SVG, clean it up in Inkscape, and generate G-code from that, and then add auto-leveling and that kind of stuff.
Who's speaking? Is that Peter or Benedict? Who's speaking?
Peter, sorry.
Peter, okay. Excellent.
Yeah.
Okay.
And for the milling, I'm now trying. So what I need is for the circuit lines that I need to have the contours of it. And I found out that you can do this very nicely with FlatCam.
Yes.
So now I'm generating Gerber files from KiCad. I load them into FlatCam, and from FlatCam I can basically create a CNC, the contours from which I basically have to cut along the lines. And from that I can generate G-code, and we've already confirmed that it basically works, only the X and Y axis are moving way too fast now. So I'm trying to make sure that, so this was just a dry run, of course.
Yeah.
So I have to make sure that the X and Y axis move much more slowly, but up until now I haven't found a way to do that. So I guess in G-code there is this F command.
Yes, F.
But the X and Y axis don't seem to react to that. So now I'm trying to do G0 space F and then 0.1 or something. Well, I'm about to try that actually. So maybe someone knows how to do that.
Yeah. I mean, when you export from the Inkscape plugin, that gives you a feed rate upon every step. But you're using FlatCam. Try to maybe like mimic the format that the Inkscape plugin gets you, because that definitely has the feed rates in there, and that should work there. So like instead of feed rate like 1500 millimeters per second, do it slower. Like, yeah, I'm not sure about the numbers there, but I know, like, I've seen some of those numbers. They were like 1500 within. Yeah. So,
minute, yeah.
Per hour, I think.
Okay, so maybe like reduce that. That, yeah.
I'll look at the SVG, the G-code from the SVG export from Inkscape, indeed. So that will probably help.
Yeah.
So the FlatCam export only sets the feed rate right in the beginning, but not in front of each command. So maybe that's a solution indeed.
Yeah. You should also take a look at our channel, video channel. We've gone through a little bit of KiCad cam file generation. So so we have the KiCad FlatCam workflow. So either between Open Circuit Institute, if you go on their website, or my YouTube channel, I think we have a video there on the toolpath generation, so you can take a look at that as well.
Oh, right.
Yeah. So yeah, KiCad to FlatCam appears to be the way to go in this workflow. That's good.
Yeah.
Mm-hmm. Excellent.
Yeah. So.
For the Unai made Arduino board. By the way, couldn't make it work up until now. I soldered also a capacitor, 22 picofarad, no, 100 nanofarad, to the pin 13 of the USB to serial converter, but that didn't seem to work, or didn't seem to help at all. We added a button, but that didn't work either, like by resetting just at the upload. So yeah, we're still trying to figure out how we can make it work.
Tom, pipe in and tell us how we make it work. So Tom did it, it worked.
Well, I'd have to qualify that. We did it partially, and it partially worked, but we weren't able to upload a new sketch from the laptop to it.
So the Blink program, did that work?
I know, we had the flashing light, but that was in the thing by default.
Okay.
It was running the default program.
Okay.
So the USB interface would reprogram it. That wasn't functioning.
Okay.
Yeah, so I don't have the full answer. We're kind of at the same level, you and I.
And now, the issue there appears to be that the part we got, the one I got from eBay or Amazon, whichever one that was, you notice that DTA or whatever, that pin is missing, right? It's a little different pin out.
Yeah, I know, but it is on the chip. the CH340.
Right.
It's pin number 13, like Tom said.
Yep.
So I soldered the capacitor to it.
Yep.
And attached it to pin 1 of the Atmega.
Yep.
So it should like reset at upload or something. I don't know the specifics.
Yeah.
But yeah, that didn't work. So
yeah.
I haven't figured out what. I measured on the strip board if there's no accidental bridging, but everything seems okay. Yeah.
Yeah. So yeah, for next time, like definitely having the same part as the guy in the video would definitely help.
Yeah, well, I thought that the pin outs from the USB to serial converters were like more or less standardized.
Right.
Which isn't the case.
No, it's not.
You have like several converters using the CH340 chip with another pin configuration. Some with the DTR at the pins, some don't. So yeah, the basic design I made was for the converter used in the video, and then those pins didn't match up. So we used wires to rewire it.
Yeah.
But yeah, that didn't help either. There's like, I'm gonna look at what message it says. Oh, there's like another one.
Yeah.
Programmer is not responding. That's what it says.
Yeah. Yep. Okay. Yep. That's so you guys are focusing on electronics, the CNC milling part, and what else? Yeah.
I have an Arduino Uno laying around, so we can use that. If the power electronics board for the dimmer is ready, we can use that Arduino to control the pulse width.
Mm-hmm.
Hey, Michelle, just as a note, this is Tom. I did upload to my Tom log a new circuit or should I say a board diagram that you might want to look at, and you may want to either use that or update your the one you have in the CAD. And I did give you a few. I sent a few notes a while ago too in an email about that.
Okay. Yeah, well, I must confess I'm a bit behind on the emails. I got like quite a few emails, and I have to tackle some problems here locally. So, but I'm gonna have a look at it. I hope it didn't change too much because Holger was like almost ready. So, yeah.
I think just pay attention to the orientation of what is the collector, emitter, and base for the power elements, because they're labeled in a weird way. Make sure you know which one you're connecting to, because between the data sheets are okay, but the data sheets.
It was a little misleading, the data sheet, but I think we got it straightened out. And I put some notes in there also about how to take an ohm meter and test it and find out the pin, which pin is which.
Okay.
So on your wiki, I should be able to find all the relevant information.
Yes, and if you don't find it, let me know.
Yeah, Tom log.
Okay. I will look into it.
Mm-hmm.
And for the rest, I don't know what Benedict is working on for the moment.
I'm replacing the PLA holder and making the PC circuit board.
Oh, yeah.
This has started bootstrapping, right?
Yeah.
Yeah.
And if I find the time, I want to build a second package.
Yeah. He's using the parts, the idler parts, to make a new support for the filament roll. That seems to be more stable. Everybody has started doing that, so yeah, we should document it. And he printed the drill holder and he wants to like build a second Z-axis, so he's gonna print parts to do that.
Oh wow, that would be interesting. Yeah, yep, that's good. And Unai?
Unai is working on the wiki for the moment. He's trying to figure out the markup language for the wiki.
Okay, very nice. So do we have any collaboration improvement notes that you guys would like to share, or did you guys find? Okay, so I pointed you guys to the Scrummy project management on the wiki there on a link from the J page. It's on the J page. Is that useful, or any comments on how we can collaborate? Or like in the last day or two that we're here, any things we can change or improve?
Well, certainly the things we're working on. Peter has been documenting it quite nicely on his log, Peter log. Or has uploaded some videos, which there's one already on Facebook. We could upload some more videos that have been made, I think. I'm gonna like make a summary of the things we did and try to update that on Facebook.
Okay.
And on the wiki.
Yeah, that sounds good. Sounds good. Good. So you guys are busy. You guys.
I didn't do it like real time because there's so much things to tackle, and I've got some new electronic components running from here to there, so there wasn't much time left to do decent documentation. But I am going to do that like after the camp.
Right.
Decent documentation about what happened, and we're taking pictures, we're taking notes, but I just don't find the time to put it on the wiki.
Yeah. Yep. We'd like to have a dedicated documentation person that basically scours the wiki and asks you guys for where everything is to organize it better. Yeah. Okay. Sounds good. So we're moving forward in an excellent way.
Yeah. Well, we did some nice work on the plotter. I have been drawing some stuff up for a pen with some spring action, which is necessary if you want to have decent plots. But I had to do some more adaptations. It turned out to be a bit too big for the pen holder, so to have something that is adaptable for several pens. The pen holder on the combined piece, like on the extruder with the pen holder, the hole should be bigger, so it can have like a cylinder shape with a spring that can hold several diameters of pens, because the markers are quite big. When you want to draw a circuit board, you need a marker with a pretty thick point, and then the whole thing doesn't add up. It has to be modified. So I have been looking into it in between stuff, but I couldn't finish it. That's one of the points on my agenda.
Yeah. Okay. Very cool. Chris, any updates on your side there? You've been sending out masks to China?
Yeah, so that took up a good chunk of yesterday, early afternoon too. But besides that, we feeling pretty good about both our D3Ds are printing well. They're doing decent plotting and enough of the milling to experiment with some materials and learning the Tool Bench and some G-code editing. I'm really excited to take some of these circuit board SVGs and see if I can't replicate some of that even on like cardboard over here. But other than that, we have the Raspberry Pis also loaded up pretty good with software. I just put some of software notes from my log onto the primary Raspberry Pi page, and trying to see how we can get in and help with the RPi dev for the rest of the weekend. So in particular, I think I've got some decent configuration on the Raspbian right now. I found a version of Cura that's working, so we're going to try and slice some prints from the tablet right to the printer.
Wow.
And basically going through and seeing if we can, how well we can configure the current Noobs Raspbian. For example, changing the font and the resolution. I found if I lower the resolution on the screen and increase the font, it's a lot easier to use. So I'll definitely, I found a couple of keyboard applications we can try and install. So I'm wanting to see where we can fit in and help with that.
What are you using for video? What app are you using? Or is it command line?
Oh, to take video with the camera?
Yeah.
Command line, that's built into it.
Okay.
But we can make the command line, we can send that to a shortcut on the desktop. The command line interface is pretty easy. We could trigger it to a button or something. I'm not sure.
Okay.
But having the simple will be just having some software. We can make some. You write a simple script and put it on the desktop. That is just the command line. Open up the camera, and they basically waits for a picture and waits for you to hit enter, and then it takes or waits for you to hit enter or take.
On the picture.
Sorry, I can explore some other.
Yeah, on the picture scheme here. Don, you want to pipe in on your update?
So I, hooked up the camera, enabled it on the Raspberry Pi. That was super easy, obviously. And then I got into some of the libraries that come out of the box with Raspbian. There's one called Raspi-Still, which ultimately is a command line interface. There's a handful of libraries and GUIs that have kind of wrapped that to make it easier, but I wasn't super impressed with any of them. So I wrote some basic, scripts to just, run a script, take a picture. Run a script, take a 10-second video. So I've got some of that documented on my log. There's I guess in the past there was a library that was used to do image stitching to a video called libav-tools. That's no longer, I guess, sort of the preferred library, so now everyone's using FFmpeg, even though there's, I guess, a lot of politics that go into that. So, but FFmpeg is a decent experience. I've yet to sort of totally dial that in and figure out how to prove that I can make a real video. I can create a video file, but it doesn't really show me anything, so I haven't yet determined if I just don't have enough stills or if I'm doing something wrong still. But I'm going to tinker with that more today.
Yeah. And otherwise,
awesome. Are you do make a time lapse application or just get some video to record onto an AVI?
So the FFmpeg has the sort of image stitching to video components. The Raspi-Still library has a time-lapse function, or I guess parameter that you can call, and so you can tell it, for a duration of X time, take a photo, every Y unit of time, and give it, this sort of file name incrementing pattern at this location, and it'll just run. And so you'll end up with, however many stills that equates to, and then you can target your FFmpeg script to go and take all those stills and generate a video out of them, an MP4 or H.264 or with all the different requirements of settings and configurations that you want. It's actually very extensive. It's almost overwhelming for what we're trying to accomplish right this moment.
Mm-hmm. Chris, are you actually using your printed bearings in your printers?
Yeah, actually, on one of them, and I will notice or say that with the current tolerances and the current how they're currently designed, there might need to be a little bit different for each axis. The y-axis ones seem to be working great, but the ones in the z-axis don't seem to be doing very well because they have too much give, and it's a much bigger deal on the z-axis. So I don't know if that's just maybe might need to be printed. Work with the settings and the tolerances a little bit, maybe, but I don't know. It could be that these are great replacements, drop-in replacements for the y-axis, but we really need to use some metal ones or something for the z-axis.
Because
not sure, but yeah.
Because of
yeah.
Because of the larger torquing on the z-axis there, due to the X. Mm-hmm.
Yeah.
But that's good.
It's doing well enough to draw and plot and print, but I can just tell it has a lot more wobble, especially when the x-axis gets far out over the bed.
Yeah, well, that's good though. So at least some decent success on it. That's good that we're using them at all.
Yeah.
Mm-hmm. Yeah. Excellent. Regarding so you guys are going to. As far as one of the outcomes of this, if we can get a nice working keyboard, if the options on Raspbian don't work, can you guys try Android or something like that?
Yeah, I found another Android. Android application that seems to be well regarded and should work for the Raspberry Pi 4. It's just even though it's built on Android, it's unclear. It's non-commercial. You can get a non-commercial trial account, but then it's a service company that's built around it.
It's NC, but you can see the source code, or you can't see the source code.
I believe you can see the source code. It's NC for personal use. It's NC for their trial version. But it looks like it's on Git as well. I mean, it's just it's unclear.
I didn't get it completely, but the Raspbian, you can make it work, or it doesn't work with a keyboard, or what was the problem?
It works great. The user experience is awesome. Like, it's fast, you can pinch, no speed problems, but the keyboard is pretty lame.
On-screen keyboard.
It's an on-screen keyboard. It's like, it's a small thing. It pops up like you have to put it in a window below the window you're working on, so it's not like a true pop-up keyboard. So it's a really bad user experience. But other than that, it's awesome. But I mean, without that keyboard, you need an external keyboard to make any use out of this. So yeah. Okay. But other than that, I mean, it's awesome. I mean, the resolution on that screen is amazing. I mean, 1920.
I'm looking forward to doing it, but it won't be for this team camp, I suppose.
Yeah.
I have a few other questions. Benedict asks when the next team camp is planned, because he wants to organize it in Hamburg.
Yeah. March 8th. Yeah. So we wanted to do on March 8th through 11th, so a 4-day. Next time. Yeah, 8, 9, 10, 11. So tighten up the curriculum. Possibly put the Raspberry Pi on the last day if you combine some of the etching or circuit milling electronics parts. Or just do like a basic first 4 days. But it's really nice to have somebody walk out with a nice product. Like by that time.
We start on a Sunday?
Yeah.
No way we could start on Saturday.
Or Friday.
We can, but the idea is that so I'm invited to Hong Kong there, and they're starting on the 8th. So we're going to do the first day on the 8th. It would be nice once again to work together, but then again, if we're there in Hong Kong, that's kind of like totally different time zone, so it's like not super collaborative anyway. But maybe if you guys want to make it a little different and do, because that's a Sunday, the 8th is a Sunday, so that might be troublesome. So the idea there was that we coordinate on everything at the same time, pretty much, so it's a coordinated effort. There's as much feedback as possible between the different groups to see some synergy. Over in Hong Kong, we're going to have probably 20 people, like already like 12 students and probably some more. So it would be nice to explore it, collaboration on a little bigger scale. And of course this thing is going to grow. Jessica wants to run this. One addition is that actually Mitch Altman, if you know the name, he actually responded a few days ago, so we're talking about him running one or participating with us. So Mitch is a big name in a DIY world. So
it would be nice to have a good video capability that we can share screens for showing what you're doing. Yeah, good video connection would be nice.
yeah, over there we're not going to have issues with bandwidth. Here we're very limited.
Hong Kong, I don't think there's going to be a problem, but yeah, that would be for collaborative efforts. That would be better, I suppose.
Yeah, yeah. No, I mean let's just keep it simple. Otherwise, we're just kind of like getting spread. It's a little harder to organize and coordinate. So, would you guys be able to do it on the 8th through the 11th?
Well, that depends. I think it's a bit short notice for Benedict.
Yeah, yeah. It is short notice, but we're going to be running that again. Like we're going to try to get a pretty regular schedule. So, like every 2 months, we do like a full camp, and maybe 9 days. We were looking at 9 days every 2 months, and then do a short one every other month, and just keep it going and build the momentum and get more people involved. So that was the idea.
I would like to start with a 4-day camp.
Yeah. Yeah. No, I mean there's a lot of content, and you want to make sure you have enough of a handle that replicating it is not. I mean, this is our first time. We're shaking everything down. We're seeing first of all if it is possible to do this. I think the results are quite positive. There's of course a lot of development to be made, but I think it's growing, and I think there's a lot of interest being generated. So it's good. And I like just like the several things we heard today, that kind of starts to show that yes, we are collaborating. We're moving things forward in a much more coordinated way than single people, right? So that part is good. Definite coordination happening. So, and the value that we provide, it's like what you're seeing right now. To do all this stuff that we're doing, it's like not particularly hard. I mean, it's not like rocket science, but in order to get it to this refined form, it takes a lot of work because everything is scattered all over the internet. There's not really other concerted efforts that are going about open sourcing technology in some integrated way. So we're paving the way for a lot of people. It's very valuable. Like, just finally having a source where, okay, now you can just do a circuit mill and it works, do a 3D printer and it works, and you have this whole integrated tool chain. I mean, the value of that is huge. I mean, it's going to grow like crazy in the future, and then the scalability and modularity. So,
it's some refinement. Well, to get the plotting and the drilling really. Like the drilling hasn't been done completely, but we're working on it. So that would be nice for a 4-day workshop. I think when you can build the printer, do the plotting and the drilling, and looking into all the software that's involved in that. Yeah, your 4 days are pretty much also with FreeCAD, some Inkscape. Yeah, it adds up.
Yeah, it does.
And we have been talking quite a lot during lunch and dinner mostly about a platform for the development being a versioning system for 3D files. And Peter, who is an ITer, has quite some experience with versioning and stuff. And like he talked about before, like automatic wiki page generation.
Oh man!
So that's something we're gonna look into. Benedict is very interested in that concept too. He has contact in hand.
You guys cut out.
He wants to attract to work on this.
Yeah.
camp that he wants to organize, like invite issue to describe what would be needed and get them on board to
Michel, let me just refresh. You're cutting out there. Let me just refresh real quick here. Guys, hello. Do there bandwidth?
I can hear you.
Okay. Okay. Yeah, Michel. Sorry, we missed the part. So Peter, with the versioning and a potential auto generation of wiki pages, which would be completely awesome. Tell me more about. We missed, kind of cut out on Benedict. Okay, I can't hear. We can't hear.
Chris still on?
Yeah. Our internet.
Yeah, I'm here.
Okay, so maybe Michel is recutting. Yeah. Chris, how has your experience been so far with Shang there? Are you guys having a decent time, or is it like very stressful, or how is it there?
Yeah, no, it's been good. I mean, it's been a little bit grueling of a build, and I feel like we've had to slow down and not get too stressed out about not stress ourselves out too much about any particular needing to be at any particular milestone, as long as we're still making forward progress, learning, and having a good time, and we've I think been able to do that. Yeah, it's a lot of stuff to cover, but I feel like getting some initial exposure to it, and then to know what's out there is hugely helpful. I feel like we've tried to come back and have more let's spend a little bit more time practicing what we have gone over, as opposed to just it's been stressful feeling I think he was feeling some stress to move on to the next thing after we have just finished learning this one thing to solidify it a little bit. So I feel like that's what we've been trying to practice as well. He hasn't come in yet today, and I'm just seeing some text messages from him today about his next thing that he has to go and do with his family. So it's I'm not sure if he's going to be able to help us with the rest of the Raspberry Pi. I'm waiting to hear still about that. But yeah, he had a really, really good time here. We both learned a lot. A great time together. He has a bunch of his notes he's wanting to add to the wiki, but he's not sure if he that's what he was going to be working on some today. So I'm not sure when will be time for that. But yeah, we were able to kept our spirits high and learned a lot. Had a good time.
Yeah, no, sounds good. Sounds good.
A lot of notes for the future. How to iterate. I'm really looking forward to is going back over this curriculum again from start to finish with you guys and filling in after this and before the next, and fill in some more of the documentation and what we've learned. When we're not quite to the gun.
Yeah, absolutely. Like, let's meet, a day or two after, like maybe Tuesday or something, and just review and reorganize. Yep.
Yeah.
Yep. That'll be good. Okay, sounds good. Awesome. Jeremy, on your side?
You guys hear me okay?
Yep.
This microphone isn't very good.
Yeah, can hear you well.
I pretty much reflect a lot of the same thoughts Chris had. It's been a good learning experience. I was definitely a little behind for a bit, kind of in the middle, but I feel like I have a good handle on everything now. And the Pi project has turned into a nice culmination of a lot of what we've learned at the beginning of the week. So
Yeah, and you're doing some good contributions on that. That's pretty good. So I like that. You're doing well on the part libraries. So we're kind of collaborating between you and me there quite a bit on those parts. So that's good. You're going to continue that today. What's your plan for today?
yeah, I've got to do some of the OS install stuff. I was kind of waiting for just to see what you guys had come up with, to see if I could cut some time out of that as far as playing around. But I plan to get that done today, and then continue to work on part libraries or parts for that case or whatever you guys need.
What's any blocks in terms of is it transparent with your next step for the operating system, or you're looking for?
Yeah, no, I just haven't. I've been focused more on the physical, like how can I arrange this. I figured it was either going to work or it wasn't on the OS. I'm not too worried, and you guys have some really good notes out there now about anything you've run into. So
Yeah. Okay. Sounds good. So yeah, we're all making progress here. That's pretty good. So I look forward to, like, my milestone is try to get everything in a case and probably do like a fat pie. Idea we'd have a decent keyboard with Chris's input so that we can move forward on it. And the European guys are kind of got their program on other things, which is good. They're developing a different aspect, but that's valid and good for them and good for us. So that's good. Go ahead.
I was thinking you'd call it a phablet with an F, not a PH, since we're making it.
Good.
I'll say what? I missed it.
So there's a concept called a phablet with a PH
Oh.
where you integrate a phone into it.
Yeah.
You're saying it should be an F since it's fat and bulky.
Phablet. Love it. Okay, I think that's it. History has been made right now for a very popular Raspberry Pi tablet of the future. So we'll call it the phablet. It started right here. Okay, great. Yeah, so we'll keep going at that. We'll collaborate here and continue coordinating as much as we can.
Yeah, for you guys, I have been trying to catch up also on the Scrummy. So it seems right now the working doc and the main wiki page for the tablet is where we're going to be coordinating on. But the Scrummy's not loading for me right now. And this morning.
So there's the J page, and the J page leads to the part library for the Pi tablet. So those are the two main working pages, and coordination happens at the top of the main J page where the Scrummy is. And you can edit that freely. You can just add your tasks and name to the thing, and it appears in a certain color for you. You can drag the things using the top bar.
Their server is down right now, or
oh, is it?
Because there's nothing coming back from the domain anywhere.
Okay. We might have to create our own lightweight implementation of Scrummy. I really like that program. It's super lightweight, and it's open to access, so you don't have to worry about permissions and turf or whatever. It's a nice thing. Very, very lightweight. You can put it up in a second, and it's immediately useful. So like the startup time on onboarding on that is like 30 seconds. You just start using it. So that's good.
Cool.
Yeah. So coordinate as much as we can. So the visibility is like working within a working dock on a Pi tablet, and then the tasks upon the Scrummy board. Those are like the two main coordination things, and then keep popping things into Facebook and other things, or send stuff over and stuff like that. Yep. Awesome. Excellent. So yeah,
right.
We'll continue going. And do we want to check in 1, 3, 4? Or keep going? We'll be in the docs. We can actually do. It's useful to do the docs where we have comments there, so we can communicate. I think that's been working well, where we comment on the things within the working doc as a means of communication. So that's pretty good. All right.
Awesome, guys.
Awesome, guys. Well, we'll see you. We'll talk through the interwebs. Okay. Thanks a lot, guys.
Take care.
All right.